viva, 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 viva!
Awesome!
This usually works.
Goodbye.
25 years of movie history there and more coming. So, hey everyone, good afternoon. I'm Michael Quandt, and I'm going to talk to you about visual effects for the next 20 minutes, as best as I can squeeze it all in. So, what are visual effects, and especially what does technology have to do with visual effects? Really, whenever you go to the movies, you watch pretty much any film out these days, there's guaranteed to be some visual effects on screen. Most people are used to thinking of it as just a green screen, replacing the background a bit, changing, maybe adding some creatures in there. But there's so much more to it, because whatever they can't do on set, we do in post. We add the magic to film. And really, the key thing there is that we don't want you to notice, right? Some things are obvious, but if you go to the movies and say, yeah, that looks fake, then we haven't really done our job. But if you go there and don't notice at all, you're immersed in the film, you don't realize that actually that giant city is just the corner of a little room. Then we've done our job. And we're programmers, engineers, artists. We're way more than just some people playing around with Photoshop, although we certainly have plenty of those. And the key thing I want you to note is that you can join this industry. Animal Logic, the company I work for, has been in Sydney since about 1991. We are now in 2 different cities, Vancouver as well. We've opened up a studio there. And across both locations, we have over 600 people and counting. In LA, we have a small studio just to sort of do all the business deals that we need to keep things running. We've done a lot of movies, quite a lot, as you saw in the show reel earlier. Quite a few you'll recognize, some you may not. That's fine. We've won an Oscar for Happy Feet, and most recently we just finished up the Lego Batman movie, which comes out later this week. So I hope you go and see that. I am a software developer. I work in the research and development group at Animal Logic, and my job is to build tools for the animation team. There's a couple of different caveats there. I build tools for a wide range of people, not just animators. But in general, I focus on the people who make the performance happen. A little bit about myself. I studied here at UTS. I graduated not too long ago, did a Bachelor of Engineering here in Information and Communication Technologies, and joined Animal Logic just after the release of the Lego movie, which had absolutely no impact on me joining the company. Prior to that, I worked in games and did some stuff on Microsoft. Shortly before that, if you've been here in previous years, Lawrence Crumpton, the Microsoft speaker, I worked with him, and that was insane. So, tech in film. The key thing to remember is every time a new film comes out, they always want to go bigger, they want to go better. The director wants to improve on their previous film. And so that means we have to keep up. As the people providing technology, we have to make sure that we can rise to the challenge and achieve really the vision of the director, because that is ultimately what the artists are trying to do. They're trying to iterate constantly and find that look that story, that style that the director wants to put in front of audiences everywhere. And so when they have a problem they need to solve, we need to work with them to make sure we can provide that technology in whatever form it may be so that they can accomplish that goal. But where does research and development come in? Where does the technology come into play? IT and those areas, you don't really think of that as part of visual effects normally. You think of the art and the artists, but you don't think of the people making the software behind it. And when people ask me, what do you do in research and development, I like to give an analogy of an artist's paintbrush. Right? A painter, the artist, comes along, they paint with a paintbrush, but who makes that paintbrush? Who comes along and actually designs the brush, builds it, provides it to them? That's what we do. When they want to make a change to it, they think up a new way of working with it. Maybe they'll snap that brush in half and they'll make a textured pattern across the canvas. We come along and look at that and say, well, we can give you a tool that's designed for that purpose, and we can help build on that and work with you to make the best possible tool for you to use to achieve that creative vision. Ultimately, we want to give you, as the artist, the freedom to create whatever it is, to solve whatever creative problem you have. Just to give you an idea of the sort of scale we work on, Lego has been a very special case. In the Lego movie, not too long ago, we calculated if you wanted to build the film with every single Lego brick in it at home and you were especially rich, you'd need 15 million bricks to build the entire film. The Lego Batman movie, for just Gotham City alone, no characters, no vehicles, none of the other sets like the Batcave or anything like that, is 220 million bricks. So we've built the Lego movie multiple times over just for one city. And we had a bit of fun. We sort of said, how would we lay that out if we were building this with real Lego? And it would take about 6.5 football fields, which is a pretty big amount of space for that. 19 meters high, which is crazy as well. But the key thing you can see there is we have to constantly increase what we do. Like, we need to give the artists the ability to just go bigger and better. In this case, it's raw numbers, but sometimes it's new techniques that they want to try out, new creatures that they want to be able to provide. A little tidbit I just got in shortly before the presentation is that in the Lego Batman movie, we used 4.5 petabytes, which is 1,000 terabytes, to store everything we made for it. So all of the different versions of every single asset we made, every final rendered image takes about that much space. And we calculated for the total time it took to create all those final images, that's just CPU rendering time, would take about 64 million hours. So, of course, we go big, and that's where our IT department comes in. They make sure that everything runs smoothly. They make sure that we can easily work with over 33,000 CPUs whenever we need it, so that we can bring that crazy number down to about 80 days. So in the sort of artistic space, performance is what we call animation and everything relating to that, creating the performance of the character. And even there's a bit of code, and it's not just the research and development group that works on that. When you look at Joker up there, as he moves around and creates his performance, an animator needs to be able to move that character around and create that. And we do that with something called a rig. Now, we have a group of artists called riggers who basically build those rigs for the animators. They work with them to figure out what they need to create and express the emotion and the character's performance, however they need to do it. And a rig there is really just a bit of logic that says when I grab something like the hand of the character, the entire arm is going to move up. Or maybe when I rotate this little imaginary control around the waist, the Lego character will rotate in this certain way, or the legs will move in this way. And it allows the artist to have a really easy way of managing the animation they're creating and build that up really quickly so that they can keep iterating and achieve that vision. When we're animating crazy amounts of things, we can't really get an animator to work on, say, hand animating every single drop of rain in that image there. So we use simulations, computers, to basically handle everything for us en masse. We want to make rain fall down, swirl in the sky, hit characters or maybe have some fur move around blowing in the wind, we use computers to handle that. And that's handled by a group that we call the FX team. They tell the computer how to do this through a lot of physics algorithms and various other simulations, sometimes just completely made up, whatever achieves the look they want to achieve. The next and sort of final step for us is lighting and compositing. The way we generate an image is we have a tool called a renderer, in our case a ray tracer. And the role of the ray tracer is to cast out a ray for each pixel on the screen. We fire a ray out into the world, see what it hits, find out what light shines on that, what if it's in shadow. We ask how that light interacts with that object that we've just hit for that pixel, and we determine a color that we want to put onto the screen. Then we fire out another 100,000 of them to just find all those minute variations, because there's a lot of random numbers here. But we can keep refining that forever and ever and ever and take an infinite amount of time to render this single image. Instead of taking 20 years to make this film, we have our lighting artists balance out the quality of the image with the amount of time it takes to render. So basically, they know how it all works. They know which parts are going to cost a bit more of CPU time to calculate, and then they can determine, okay, we'll tune these bits to give you the best quality image without taking forever. They serve a double role in our company as compositors, and they basically bring all of the different layers they create. Smoke effects, we like to sort of create them separately, bring them all together, and then you've got final image like you can see up there. It's not just thinking about the now, it's also thinking about the future. We need to be able to anticipate what's going to happen, because we don't want to start working on a film now and then in 2 years it comes out and it looks really outdated. So we have to keep thinking about what's technology going to be like in 2-3 years. How are people going to expect to consume that? They're going to all watch it on VR devices. Is 3D going to be a thing? And we have to try and figure out, okay, how are we going to make stuff for those devices? As well as how can we use them within the company to make filmmaking easier? So how could we use VR helmets like you see outside, all the booths there have them, to create films? How can we give it to a director to let them see inside the world instead of just through a 2D screen? Maybe they can explore the Gotham City in VR. So we have to think about that and think about how we can go forward using new technology. So hopefully at this point you kind of know why VFX, but here's some other reasons why it's such an awesome industry. The thing is, we get to create the technology that you all see on the silver screen. I made the face animation system for the Lego characters in the Lego Batman movie, and millions around the world have seen that. And speaking of around the world, we are a truly global industry. We're in so many different countries, as you can see. Animal Logic by itself is already in Canada and Australia, but you have the chance to work in so many different places. And the thing that sold it for me is that you get to live the behind-the-scenes feature on that Blu-ray. You get to be a part of the process of making the film. Quick summary of sort of what we went through, what we did to get here. There's some engineering, there's some maths, but you also don't necessarily have to study. If you don't feel like you can get into uni, you can just go through high school, have a passion, make something, and then when you show it to us, you've shown us you can create something that's relevant, and that's probably the easiest way to get in. But certainly going to university, as one person went to way too many courses there, certainly helps. Really, that's what we're looking for. We're looking for people who can solve creative problems, who can work in a team with other technical people as well as artists to solve their problems, the creative ones they have, as well as our own technical ones, and achieve that one vision. I'll make special note, we have a work experience program that we run twice a year, so I encourage you to go to our booth, find out about that. We have a much longer, sort of week-long rundown of every step that we go into to make a film, and it's certainly better than the 20 minutes I've tried to squeeze in here. So I'd encourage you to check that out.
Use models for the animated characters, or are they all made on the computer?
It's kind of a mix. So Lego is a special case where there are real toys, and for a lot of the stuff we have a digital version and we build up pretty much everything digitally. But in the case of the Lego movie, some parts of that were real Lego. So we went in there, they created the characters, Lego worked with us to build up the sets, and then we filmed real Lego for that. But in the most case, for the Lego Batman movie, it's all 3D models built on the computer.
For each of the steps of the animation process, what is the longest taking?
Probably, to be honest, story. That can go on for quite a long time. But past that, I'd say animation itself can take quite a while to get the fine, detailed performances that you come to expect on these on the screen.
Hi.
Yep.
What CPU and GPU are you using to render your animations?
So we use a mix of them in our render farm. Those 33,000 cores, we use a lot of Xeons, quite a lot of them. There's a mix, a couple of different generations of hardware there. Just over the years, we've built it up because it takes a really long time to order in 33,000 of them. On GPUs, we use workstation stuff, Quadros in particular, and those allow us to sort of push the graphics that we need, but that's only for real time. That's only for the artists working on their machines, not for the final image.
What other films and projects are you working on at the moment?
Right now, we are working on the Lego Ninjago movie, Peter Rabbit, which has just finished up filming in Centennial Park here, and we've, I think, finished on work on Guardians of the Galaxy 2. And any more than that, we can't say yet.